you already know probably. This year we did it in New York and Berlin. Those of you who visited these events can remember that. And the rest of you who wasn't there, you can watch the video recordings on our YouTube channel. But this time we're not alone. The Layer 2 Meetup Osaka edition is organized by Geo Protocol together with Celer and Nervos, who are co-organizers today, and we're thanking those great projects for that. Also, we want to thank the teams who supported this meetup, namely Matic Network, POA Network, Offchain Labs, Cartesi, Matic Capital, and of course, CoinFund. Thank you guys for your support. Thanks to you, all this. This time, this is really a community event, not just our own initiative, as it previously was the case. So today we have great speakers who represent groundbreaking projects, Layer 2 projects. We will announce them in this course of this event. Today we will discuss the future of Layer 2, its mass adoption, UX, and business-related topics. So for the agenda, we will have 7 lightning talks and 2 panels. After the first panel, we will have a short break for sushi and pizza. Yeah. And also at the end, we will be able to eat, drink, and network. Alright, let's begin. And the first speech will be delivered by Junga Liu of Celer Network with the topic mass adoption of Layer 2 scaling through real money esports games.
It's a long title, but I hope the talk will be interesting. I guess about 7 minutes. I'll try to get to the most important points. I want to let everyone be aware. First, why are we even starting doing this? It's simple. That's it. We want to scale all the blockchains, and by all, we really mean. Luckily, we started early last year. I would say we got the team together pretty lucky. We kind of realized the thing and did a very fast iterations. Then we're in this stage. Basically, we said, oh, we can't go out and tell people we have a super awesome payment, fast, instant finality, all these fancy features from State Channel. But people ask, what do you use it for, right? So now welcome to what we call now Celer X. It's the first vertical we find on top of the Celer network. Think about Celer network is more like horizontal Layer 2 to accelerate all the Ethereum or all the other blockchain using State Channel. And Celer X is the first vertical we say, oh, mobile. That's why the title is so long. Mobile, real money, esports. I'm happy to share some of the numbers. We have been in actual production, real production for a few months. So these are the real users from across the world. How many money, blah, blah, blah. Especially for the number of countries. It might not seem like, usually people say there are more than 200 countries in the world. But if you see this map, it's actually really, really powerful. It actually inspires us to see, oh, the blockchain, it does make a difference. All the yellow part is our users, the countries we have users in. And the blue part either have no power, no internet, or it's forbidden by the US government. So yeah, that's the power of blockchain. So you heard the initial, the opening talk from Ethereum Foundation say, oh, the equality, the fairness, the world peace, right? We see that clearly from this map. Yeah, and on the other side, we never consider ourselves as a good game developers. So we tried several games. We said, yeah, that's it. So that's why we actually have a dedicated developer portal for existing game developers, not blockchain developers. And luckily, we got many of already signed up. Actually, get on the pipeline, we have more than 100 games already waiting for review. Yeah, and the effort to onboard a normal game like HTML5 game developer is within 30 minutes. So like there's no understanding gas fee, transaction, like account. You know what I'm talking about. If you have written a single line of Solidity, you understand the pain I can feel. Yeah. For the normal game developer, they don't need to know this. So to quickly recap, a large-scale production system that's actually running for a few months with real user, real money flowing through the system, everything's heavily optimized for efficiency and performance. And also, we have been mostly driven by the real-world use cases. Like the user came to us and complained and said, why you have a spinning wheel in your app? You could go and say, yeah, there is an on-chain transaction. What is on-chain transaction? Then we say, forget about it. We handle it. You will never see a spinning wheel again. Right? That's our rapid iteration. I'm actually do bi-weekly mobile app release right now. And also, as part, you might be aware that, especially for state channel, there are many kind of interesting projects also in the field. And we kind of see, instead of every project try to somehow in certain way reinvent or rebuild the wheel, we say, how about we come together? That's why we have this, if you were in the talk by Liam on the second day, yesterday, the state channel kind of standardization process and the spec. Right? And we are part of the driving, if you see, because we have gone through the path, we say, oh, that path doesn't work, we tried. And this is why it didn't work. Let's try the other way. And as I mentioned earlier, more than 250 non-blockchain developers already on board. So if you're interested, we have the smart contract everything open source on our GitHub, and also we publish our full protocol spec. And the spec was written in mind for people with non-technical background. We read from the introduction, the background, to get why are we even doing this, and what's the reason we decide on this state channel. There are different ways to do layer 2 scaling. State channel is just one path, right? And also, it's kind of layer, not layer by layer, but kind of a deep dive, slowly take you step by step into very technical specific, up to the level you feel comfortable with. And of course, as I mentioned earlier, game is one vertical, and I want to make it absolutely clear, Celer is not a gaming project. Right? The core is still this super efficient layer 2 state channel based payment network. And we already have the open source web SDK, and we can already see in several East hackathons in San Francisco, in Boston, there are very interesting ideas built on top of this. Like you could do, because again, the state channel enable this kind of highly interactive, high frequency, almost zero latency, definitely zero fee transactions. You can do very efficient derivative market. Think about high frequency trading, but on layer 2 blockchain, right? And of course, all this like decentralized exchanges and all the other like streaming payment. That's some kind of thing people talk about a lot on the IoT market. Then, if there's kind of a very small group of super advanced developers who say, I don't write JavaScript. I only write strongly typed, formally verified, whatever, system level language. Our architecture actually is designed to be modular and extensible. You can see, the purplish blue. This part, the blue and slash green, is our implementation and design. It covers almost 99% of the use cases. People care about, like Boolean payment, meaning do I pay or not, or numeric payment, I will pay based on the result. Right? But at the same time, you can plug in your own definition on top of our bottom line primitives. Like you might heard about something called Nitro, and actually we tried something using the simple Boolean conditional payment we have built as a bottom. And it's actually pretty easy for us to support it. With two, kind of a Boolean circuit, we can support Nitro. Yeah, so that's all I have. I hope I still get time right. If you have any questions, we can check offline. Yeah, thank you.
Thank you very much. So our next speaker is Paul Wang, Chief Product Officer, Nervos, and his topic is towards a better sidechain security model, a layer 1 perspective. Welcome.
Thank you. Hi everyone. This is Cypher from Nervos Foundation. Nervos. Today my topic is about better sidechain security model from a layer 1 perspective. When we talk about layer 2 scalability or layer 2 solutions, we always hope we could figure out some solution with all of these characteristics, like performance, flexibility, security, and decentralization. But in practice, the mainstream layer 2 solutions, they all do some lot of trade-offs, like state channel. You know, state channel is very high effective. It could handle huge throughput. But to effectively change signatures, the state channel only supports limited predefined set of participants. And for plasma-like,
I would say that this meetup beat our records. We had like twice as much people as we had in New York and Berlin. That's partially thanks to our co-organizers and supporters. You did a great job, guys, so we could did our job as well.
Yeah.
Thank you very much. Our camera switched off after some time, so we've lost an hour of our meetup. So would you please repeat everything that you've been saying for the last hour? No? Okay. Then we will keep it in our memories. Okay, I think we can continue now. And I would like to invite Mr. Anurag Arjun to the podium, co-founder and chief product officer of Matic Network, with his great speech about UX and DX at Layer 2 solutions, which means user and developer experience, if you didn't knew that already. Welcome!
Yeah! Okay. Hi, Chris and Okay. So this is going to be very short, not too long. I've been warned to keep my presentation to a maximum of 7 minutes by the geoprotocol team. So I will try to keep it under 5. So very quickly, I mean, we've been discussing, the panel was very good. I just came a little late, but very high quality opinions by the panelists. But today I'm going to talk about a little bit more down to earth topic in terms of user experience and a little bit about developer experience in layer 2. Most of this comes from my learning that we've done at Matic Network over the last 2 years. Some of it might come from a sidechain perspective mostly, but it should apply equally to other layer 2 solutions as well. In terms of the things that we need to keep in mind while designing a layer 2 solution, apart from the security perspective, is also in terms of how big the learning curve is also going to be. So once you've kind of defined the core strategy behind or what approach you're going to take for the layer 2, you also need to optimize for developer experience. And some of the learnings that we have mostly around reducing the learning curve, right? Like minimizing developer friction. So what kind of steps do you take? What kind of design choices do you make? And we recently, from Matic's perspective, we recently released support for plasma predicates. And for those of you who don't know, plasma predicates can be used for doing generalized plasma or generalized state transition for plasma. Those are, at the moment, not as easy to write as Solidity smart contracts. So we need better tooling for that. The strategy we have taken is we are pre-building predicates for most major use cases. And of course, if you want, you can write the predicates that you want for your specific use case. But in terms of just just minimizing migration friction, pre-built predicates are one optimization that we have done.
we also, in terms of composability, just ensuring composability, right? So we have like a Matic sidechain, you can deploy your dApps already, but Solidity developers, especially in Ethereum, are already used to a lot of infra that is already available on Ethereum. So someone wants to build like a new DeFi app, they already know that they have something like Uniswap already, which they can just kind of call and use. So replicating the same kind of developer experience on an L2 solution requires us to also think of how to port existing protocols also onto the L2, or at least providing access to. Now that may be on the same chain, it might be cross-chain, so all those things have to be taken care of. And one important thing which slowly is getting in shape on Ethereum and we need to do on L2 is things like component abstraction, especially in terms of front-end and back-end libraries and widgets. Just to give you a broad example, in Plasma, there's like, when you move funds from Ethereum to Matic, and when you want to move them back, there is like a 7-day withdrawal period, which we are kind of trying to mitigate by things like fast exits, which is like a 7-day kind of a loan. But in terms of developers wanting to integrate this withdrawal, even though we had like a very simple to use Matic.js library, which is like 150 lines of code, very easy to use, and when you want to use the code, it's just like 2-3 lines. Even though it's still, developers have a hard time kind of wrapping their head around withdrawals in Plasma. Why does it require like a 7-day period? How do I handle that in my front-end code? So we just went ahead and built like a UI widget for the withdrawal, which has like a backend component to it as well, which kind of does the waiting and stuff like that. But what I'm trying to impress upon here is, for any L2 designer, these are very imperative to ensure adoption as well. And finally, good documentation. The reason why there are so many developers on Ethereum right now, because there is now good documentation available. You go to Stack Overflow, you can find a lot of useful stuff there. L2, all the stuff is very new, there is very minimal documentation. So apart from building the protocol out, you have to concentrate on good quality documentation. So that's kind of it on, I just wrapped that section on developer experience pretty quickly. Moving on to the user experience. And what we desperately need for layer 2 solutions to actually thrive is L2 first wallets or layer 2 native wallets, right? In sidechain specifically, you have this notion of multiple chains. So I just put a screenshot over here. So this is the screenshot of the Matic wallet that we're building. It's like a L2 first wallet. If you see the second screenshot, you have 2 networks there. So at the moment, users are not even fully conversant with the idea of one network, which is Ethereum. And when we say layer 2, it means that users have to wrap around their head for 2 networks, and maybe more in the future, right? So how do we solve that, right? And so that question is a very important thing in terms of just helping users out to use this fantastic technology that we're building out, right? And so the third screenshot that you see is just the movement of funds from Ethereum to the sidechain, or Matic in this case, right? So what we have tried to do in this wallet is kind of replicate the Venmo experience. For those of you in the US, they will know, but for others maybe. So Venmo is like a wallet where you can pull funds in from your credit card, and then you can pay through Venmo to merchants and so forth, right? And there, it's very intuitive to the user that they're pulling funds from their credit card to their Venmo account. And so that's what we are trying to kind of replicate. And that's these are the kind of mental models that will be useful for onboarding users to L2.
So the next speaker is Alex Kolotov from POA Network, and his speech will be about arbitrary message breach, the missing piece of Ethereum interoperability. Welcome.
Hi everyone, one more time. So my name is Alex, I'm from POA Network. And as I said, I'm mostly working on cross-chain bridging solutions. So short deep in history. So our first breach was run from very basic idea that we need to have additional liquidity for our POA, and that's actually we use it in POA network. So, and that's why we needed to transfer by somehow our POA from POA chain to Ethereum mainnet as ERC20 token, and that's why we ran the first breach in May of last year. It was called native to ERC20 breach. So, and the next breach we built, it was, you know, we were inspired by the first breach, and we started thinking what new experiment we can do, and we thought that, okay, what if we can breach ERC20 token, and every time when the user will breach this ERC20 token to some chain, the breach will mint a coin. So, and we use for this stable coin DAI, and just now the breach is working. So it is ERC20 to native breach, and it's every time when the user transfers some token, actually his tokens from Ethereum mainnet to XDAI chain, so the breach will generate a total supply. So, and it means that now we have XDAI chain with stable coin, which, and if user performs some transaction in this chain, so it means that user pay by US dollars, because the stable coin is pegged to the US dollar. So, and these experiments show us that lots of chains could be connected to each other by the breach, and you see some adoptions which will be done by different projects. So, and what if you need some transfer, not only assets from one chain to another? You can what you can do. So you can modify the breach to transfer some information, and this it will. You know, in this case, you need to set up your own environment, so your own set of oracles, monitors, and so on. But what if we do more generalized way? So, and how we can do this in more generalized ways? So not only transfer assets, but also transfer some information from one chain to another. And this is the tool we get. So if you look at the features which provided by EVM, so actually we see that we can use call functionality when we provide a bit coded method descriptor and data, and the call, if we pass this, you know, set of bytes to the call, so this method could be can be called, will be invoked actually on some contract. And let's look at this picture from another side. What if we can do a B encoding for this method descriptor and data on one chain, and pass this information through the breach to another chain? So it means that in that another chain we can invoke that some contracts which we targeted with this method. So. And by doing this, we can you know, transfer everything. We can transfer some information about, you know, NFT tokens. So we can transfer information about, for example, if we have some decentralized exchange, we can transfer some rates of tokens to another chain. So we can use this for some purposes. And what we actually just finished now, so we run this arbitrary message bridge so far on test nets between Sokol and Kovan. So, and we prepared a few examples which can be used by any application to, you know, to build their solution on top of AMB. So, and this example actually is to transfer cryptokitties from one chain to another. So, what we do, for example, I'm Alice, and I would like to transfer my cryptokitty from one chain to another. and actually I approve the application need to perform some mediator contract, which will be which will perform all operations related to transferring this NFT or logic to transfer NFTs. And what is the logic? So first of all, this mediator contracts becomes new owner of the token. It is some specific key. After that, this mediator contract gets the information about the key and code all this information. So I mean, a token ID, ownership, and all this metadata to the together with the meta descriptor to the some message, transfer to the bridge contract, the bridge transfer this information to another side, and the mediator contract on another side actually mint new cryptokitty with some specific data. So, our next step is to deploy these contracts and run the bridge on next week between mainnet, Ethereum, and XDAI. So, and it will be showcase for arbitrary message region. And the NV components are contracts which will perform all the logic. So we do multi-sig for validators. So we actually manage validator sets. So we do some limitation of gas in order to, allow application to actually to secure the bridge. And the other component is the Oracle, which will just listen events on one chain and send confirmation to another chain. And the monitor to check the health of the bridge state. And as I said, it is already done. So we will run a showcase on next week, I believe. And thank you for your attention and happy bridging. Questions?
Yeah, questions? Here.
Thanks for the talk and the example with NFT. I'm assuming when you are staking and when you are minting a new NFT on the other chain, you want to delete the one which is in the source chain. How it happens when there is a failure? Like if the transaction will fail on the other side, how you are going to
Yeah. So thank you for the good question. Actually, all this is described in the documentation we already have. First of all, there are two strategies, and for this particular bridge, I mean to transfer cryptokitties, the strategy is the following. So when we transfer from main Ethereum to the XDAI, for example, so it means that we lock the token on the mediator contract and mint another token on the XDAI chain. But in the opposite direction, we will burn this token and unlock this token on the main chain. But the question was, what if something goes wrong, right?
Like it's a function you are calling on the other side, so requires success.
Right. So we provide on the AB contracts, we provide tracking of failed transactions. So if your call, the contract was failed, so you can always, invoke special function on bridge contract, which will say, okay, this operation was failed, and that's why we need to transfer this information back to this mediator contract on the originated side. And this mediator contract can be
a bridge function on a source or on a
yeah. Imagine that you can, by some reason, you fail to mint this token here. So after that, you as a user will call the mediator contract special function of mediator on mediator contract. On the bridge contract. This function will the information that the mint operation was failed. Exists on this contract, and after that, the home bridge contract will send the notification to foreign bridge contract to notify mediator contract that this call was failed, and that's why you need, for example, unlock the token. So so operation will be you can revert this operation. Right?
And there's another. How the bridge are working? Like those oracles, are they trusted? Like third parties?
Yeah, it's actually the same consensus as POA network performs. So it's POA, it's like multi-sig. So we have some set of trusted parties, and we have multi-sig, some n of m, and if n parties confirm that they actually saw this event on this site, so they will transfer this. Transfer this information to another side of the bridge, and the bridge will perform some actions.
Okay, so they transfer the state root or something like you have mentioned, like they see event. So for each event, they just like do that, or they transfer the state root and then.
No. They transfer just if the bridge is used extensively, so it makes sense to transfer just state root or for every bridge, for every block. But
we continue, and the next speaker is Marco Bella, founder and chief business development officer of Cartesi, performing off-chain computations on Linux infrastructure. Please welcome.
Last night we were discussing with the colleagues and concluded it wasn't worth the effort to convert a number into a string on Solidity. Take a moment to consider this. Developing for blockchain is tough. On the other hand, if you take Linux, application built on Linux can benefit from over 30 years of software development, software tools. And you have OS resources, libraries, programming languages, and it's the composability of these software tools that enable the massive growth of innovation that we experienced in the past and we're experiencing today. So compared to traditional app developers, that developers have very limited tooling and need to comply with very strict computational limitation on chain. So we want to help creating a decentralized computer that scales and provides the app developers with the tools they are familiar with. So with this vision in mind, we created Cartesi, a second layer solution that takes complex computation and brings it off-chain, while preserving the security guarantees of the underlying blockchain. So off-chain computation will perform on a deterministic RISC-V emulator, capable of booting an entire Linux operating system. In other words, we're bringing Linux to software development on the blockchain. So the first step towards this vision is the Cartesi core. It was implemented in specified in our tech paper, and right now is implemented in open source on Meetup. You guys can check it out. So in Cartesi core, what happens is that the blockchain specifies a computation that is performed off-chain, but the party is involved in the computation itself. Each party is responsible to run the computation and defend its own interest. If one honest party perform the computation, he is able to claim to the blockchain and defend himself if there's another opponent that is cheating. So the Cartesi core is composed of sets of components. Each component has an on-chain piece as well as an off-chain piece. The most important component is the Cartesi machine. The Cartesi machine is the Cartesi's VM. It's where the computation specified by the blockchain is run. It's composed by an off-chain piece as well as an on-chain piece. Off-chain, we have the full state of the Linux machine, and off-chain is where the entire process runs. On-chain, we have a representation of the full state that represented a Merkle tree root hash, and we also have an implementation written on Solidity of the RISC-V emulator that matches with the off-chain implementation. So in this on-chain implementation, we only need to run a single instruction in case of dispute, so in the rare case of dispute. And in order to identify this single instruction, we use an algorithm that costs a log of the original computation that happened off-chain. So this kind of algorithm that I explained before, it's similar to the one used by TrueBit. It's called verification game. And essentially, you only need one party that is honest in order to defend the interest of that. And in Cartesi, the difference is that parties need to perform the competition and defend its own interests. So that's the difference that we have with Trubit. So in Cartesi, we run a RISC-V virtual machine. So RISC-V ISA, there's an open standard that is getting a lot of traction from the community. And even though the instruction set is quite small, it's able to proof an entire Linux operating system. The particularity of our machine is that it's self-contained, deterministic, and reproducible. And what it means is that if I mount the Linux on top of it and all the software that I built, I inherit this kind of characteristics. So we are developing as a first demo of our tournament of fully decentralized tower defense game. So for the tower defense game, we decided to use a simple design in which the data availability is guaranteed by the blockchain. So what we do, we store a comprised log of the moves on chain. Essentially, we are able to pull the data from there. So even though this is a simple design, in the tower defense game we have a numbers instruction that is an order of magnitude above what the blockchain can support. It comprises a billion of instructions. And the particularity of this fix is that in order to develop this program, we use TypeScript and JavaScript. So we use mainstream software tools while preserving the decentralization and the security guarantees on the underlying blockchain. So to conclude, Cartesi is a crypto-economic protocol that penalizes parties that are cheating the computation. We are able to do that when only one single honest party is able to perform the computation and defend. And the system is able to perform complex computation involving large amount of data. And these computations are performed on a Linux VX that mount input and output drives. Time is up, but if you guys want to know more, you can scan the QR code, or you can ask questions to my colleagues on the back or to me. Thank you.
Okay, hi guys. How do you enjoy Osaka DevCon? Yeah, cool. So there will be a short topic before the last panel. And the topic is blockchain and DeFi in terms of UX. I want to discuss, do people really want to use all the cool technologies, the state channels, plasma, private keys, education arcs, and all this cool stuff? Okay, as far as I know, they really don't. Why? I will tell to explain you. So 10 years ago, the Bitcoin was launched, but what we've seen now, that a lot of people still use the custodian services to hold the crypto. And it is really crazy, you know. A couple days ago, I tried to use the MetaMask mobile application, and that we have seen that you can create a state channel there. But to open the state channel, you should press the button deposit funds. Is it good? What do you think? I think it's really good word here, because people really know what is deposit funds. But if you will write here the create state channel, you should explain them what the channel is. And I think that they could maybe not understand what is that. So, in my opinion, people is very conservative in about new technologies. And for example of that, if you will put the frog to cold water, it will jump out. But if you will put the frog to a warm water and heat it up gradually, it will boil. Yeah. So now, who has a Telegram messenger? Please hand up. Yeah, cool. I'll ask you to scan this QR code. It's our Telegram bot with really simple UX. please scan it, and you will receive some gift from Geo. Yeah, press start there. I'll wait. Okay, and now I'll ask you to scan the next QR code. Is our layer 2 community chat. And there I will try to create some crowdfunding. For those. Okay, this is this QR code. Yeah, and this is crowdfunding. You can participate by pressing send. Just try it. Yeah.
Hi everyone, it's Yanis. I'm one of the founders of Monday Capital. Monday Capital is a fund. I think it's based in San Francisco, New York. We're gladly in Japan for the last 8 years. We're quite different from the other funds in that every partner is an engineer. So we're not bankers or financiers, we're just founders and engineers. So we try to be very critical in the product we see. And we have a specific focus on UX and production systems. So let's start by introducing yourselves, like starting from.
Hey everyone, I'm Vadim. I'm from Geo Protocol team, and our protocol allows to build like financial internet where each user, it can be devised like a common user, has an opportunity to use its own node to interact with different applications and to interact with different assets. And in terms of Bitcoin and Ethereum, it's like universal Lightning Network. Yeah, that's it.
Hello everybody. My name is Chris Swinner. I am the co-founder and CEO of Reach. I have good news and bad news. So the bad news is that blockchain will never be anything more than a niche technical solution unless developers actually start coming into the space. The good news is we are actually fixing that problem. So what we're doing is we built a dApp programming language that abstracts away the complication of blockchain away from the developers themselves, so that traditional developers can come into the space and develop. And then through the compilation process, we automatically formally verify the output, and we output the entire dApp, not just the smart contract. So we make it so that traditional developers can come into the space, build pretty complex dApps, and feel confident about what they output. And we found that with using our programming language, it allows for a developer to create their dApp in orders of magnitude faster than they would previously.
Hi guys, my name is Patrick McCory. I've been doing research on Bitcoin and Ethereum for about 6 years. I recently quit my job at the university to pursue Pisa research full time. And I guess my ultimate goal is that I sort of foresee cryptocurrencies being this open source, permissionless, and ideally off-chain financial system. So we're going to do our best to make sure that actually works and gets into the hands of anyone in the world, really.
Hey everyone, so I'm Harry Kalotner. I am the co-founder and CTO at Offchain Labs. And fundamentally, we're building layer 2 scaling solutions to enable applications to run on blockchains that are infinitely more complex and infinitely more powerful and cheaper than what we see today. A lot of the current apps being produced for blockchains are extremely limited in what they can do. And it's not for lack of imagination, it's lack of power and tooling. And we want to help be part of the solution to that.
Yeah, hi, I'm Anurag, co-founder and chief product officer at Matic Network. Matic is a layer 2 scaling solution based on Plasma. The main objective is of course to help scale dApps, but we also have a strong focus on building developer tooling to increase developer experience and also user experience from a user experience level, just to enable more users to use these dApps.
Yeah, hi, I'm Binda Liu from Celer Network. I gave the first talk, if you missed that. It basically talks more about the gaming. Basically, we see the blockchain is all the good and everything, everyone's happy in this community. But there's a bigger world out there, and we're trying to bring more people coming into the crypto world to enjoy the fairness, all these benefits the blockchain bring us. Oh, I can take it. Perfect.
So actually we all agree. There's no usage. We are just building blocks. Right? We don't know if we ever going to use them. So the question here is like, and since the layer 2 meetup, like what do you think layer 2 is most usable? Like what kind of users? What kind of user we try to attract and use layer 2 solutions?
Yeah, I feel you got the mic in my hands. Yeah. If you see what we put on our website, we literally said bring internet scale to every blockchain. And internet scale literally means the internet experience. If you go to a mobile user today, say, hey, are you okay to wait even 5 seconds for this thing to finish? To see a spinning wheel? They will say no. And it actually shows in our user data. We literally keep close track of the user metrics. There's kind of a common metric data out there in the mobile app developer community. Every 5 seconds of spinning wheel lost you 1/3 of the users. And after one on-chain transaction, you have 0 users left. That's it, that's it. And no kidding, and no joke. If you go download the Celer app today, from your initial onboarding to you have the state channel available, you don't feel the latency. Yeah, that's how, I would say the short answer is make it feel like an internet app. And that's only a layer 2 solution can give you. Yeah.
So while I would like to kind of quote some use cases that we are seeing early, I mean there are games being developed, payments, exchanges, etc. But I really feel like we are so early right now at this stage that these use cases are not very apparent. I mean I strongly believe that some of these use cases that are very big, become big on blockchain are some of those we have not yet imagined or encountered. And I just hop back to in terms of developer experience, right? When you're a developer and you're building like a startup of your own, you don't target like I want like 1,000 users or 10,000 users. Yeah, and I'm always every developer worth his salt is, or every startup guy worth his salt is always aiming for the moon. And no one literally develops saying I'm happy with 10,000 users. I want like 1 million or 40 billion users, right? And so those use cases, when we take them as parallels to what is possible today in Web 2, like if you want like Uber or a social network to work on blockchain, I think that's not a very good idea. So some of these use cases that will come up, I think will be phenomenal when we discover those. My friend Chris, and I will copy his quote from the last panel I was in. He said that like on the mobile app store, 1 in 10,000 developers actually builds a successful app. If you take the same metric and apply to blockchain, I mean, do we even have these 10,000 app developers, right? So probably. So yeah.
I'll say for the new So, to me, there are kind of two questions here, really. I think one of them is really hard to answer, and one of them is really easy to answer. So, the first part of the question was, what sorts of applications is layer 2 good for? The answer is to me pretty obvious. All of them. Anything that you can do in layer 1, there is a layer 2 solution that can accelerate it. There are a variety of solutions, and they have trade-offs. But to me, there's no application that will not benefit, at least in kind of some way, from the acceleration the layer 2 system can provide. The bigger question is, what applications is the blockchain good for? Ignoring the whole layer 2 thing, and I think kind of most of the answers you've heard here don't really have anything to do with layer 2, really. It's just the blockchain in general, and that is one I don't have a great answer for. I mean, I think that, to me, the magic of the blockchain is still disintermediation as a technical term, but the lack of trust, that I can interact with other people online without having to trust anyone. And I think seeing how tools and projects and communities evolve kind of when the need for trust, which is kind of expensive to build, is removed, is pretty awesome. So I'm looking forward to seeing what everyone builds.
Awesome. I have a bit of a pet peeve with all of this. So people say cryptocurrencies don't have users. So I'm going to ask you guys. There's two parts. We have users, and Offchain has existed for a very long time. So who here bought cryptocurrencies recently? Who did any trading? Raise your hand, you bought some, you bought some, you bought some. You bought it off an exchange that was Offchain. And that's really important. So Offchain exists. You went on an exchange, you bought some coins, you traded them back and forth. And that's actually the use case where we're actually building as a currency market. A publicly verifiable, auditable, and I don't know, permissionless currency market you can buy and sell your tokens. The difference is that Offchain so far has been fully custodial. You know, the exchange has custody of your funds, they get hacked, they lose all of your money. So really the first use case for Offchain, as in layer 2 protocols, is to allow users to have self-custody of their funds while using an exchange or trading their currencies. So the use case is there, Offchain is there, layer 2 is letting you have self-custody over those funds.
So I'm one of the people that says there is no users on blockchain. And it's because I don't believe that trading coins based off hype and not utility is actually a user. I think that we'll get there, but the sad truth is that as shitty as layer 1 is, it works for what it is today. Layer 2 is a huge, is going to solve a huge problem eventually, but it's not today's pain point. I know this for a fact because I've gone and talked to developers about why are you not building the blockchain, and 0 of them have said because it's not fast enough. If they make a mistake, which they will make a mistake because of all of those 2 other things that I've said, there's a good chance they will lose all their money. So why on earth will they come into this space and build a decentralized application with all those risks? And the truth is, they won't. I've been trying, I've been talking, I've been trying to educate quite a bit, and all of those 3 things need to be changed before blockchain can actually be successful.
What I really like about layer 2 is that really helps for common users to get closer to crypto. And I agree with Harry that there are a lot of cool solutions that can be used by layer 2. It can be obvious cross-border payments and even for streaming, for example, spam chain, it's a good example of
That's the first example coming to mind. I like it.
Always.
And my favorite is the Internet of Things and energy market. There also can be cases where layer 2 can be applied.
And since you're holding the mic,
yeah,
what's the single most important thing that Geo did to create adoption?
My team, we are developing a few products to deliver them to common users. The first one is P2P payment system. It's local, it's for Ukrainians mostly, but we would like to scale worldwide. The next product is Alice Bob. We talked about this. It's a Telegram bot where you can exchange by cryptocurrency, and the general idea to make for common user to send Bitcoin from Telegram, so your friend will receive or any other currency in WhatsApp, for example. And other product is for fast and cheap transfers between the cryptocurrency exchanges, so arbitragers and traders could transfer assets very fast and cheap.
Chris, so since you're building this awesome language, right? So how do you get people to use it?
Well, that's actually a great question. How do you get people to use it? Our go-to-market plan has a couple of different angles. Number one, because we don't have a token at all, most.
That's a bad thing.
Well, I mean, it's actually a great thing because protocols, we're no longer competitive with protocols. And every protocol that we've talked to so far has been 100% willing to partner us to actually bring us to their community because we solve their biggest pain point of bringing users to them. So number one, the partner path has actually been a very good thing so far. Number two, we just announced and actually came out of stealth this week. So we don't have tons of users yet. But the plan is that we're going to actually start doing the hackathon circuit. Now, what we found is that I said this earlier, but for example, the workshop that we did this weekend was a multi-sign wallet that took only 50 lines of code and it output the entire DApp. That traditionally would take a lot more code, and what it's going to allow us to do is we're going to start going to hackathons, and it will give us an unfair advantage because we'll be able to build very complex apps very quickly and hopefully start winning things. When that starts picking up, I believe that we'll first start taking over the DApp space, and that will be the next step to actually take over the world.
So I think you're a huge fan of like trading or payments. Do you?
Well, me? No,
Do you think that's the killer use case? Or?
So basically, cryptocurrency is just a financial system. So over the past couple of years, I've been actually trying to understand how the financial system works. So let's look at Uber or WeWork. Why would you buy WeWork stock? They don't make any profit whatsoever. People buy because, WeWork stock go up. It goes up, everyone makes money. And actually, cryptocurrency is very similar to that. So when you actually look at the heart of what's going on, cryptocurrencies is this financial system that anyone can access. You have people in their bedrooms writing these little trading books.
So do you think like compliance in the existing system and compliance in blockchain will exist soon?
So basically for a bank, if I'm going to receive money from a customer, if I get it from another bank, they actually tell me information about that customer. Then I know they fulfilled their KYC duty, and they also send me more information to convince me they did their KYC duty. So that's how banking works today, and that's why all the compliance and KYC is around that. Their problem is that if they get money in cryptocurrencies, and nobody goes from one exchange to the blockchain back to the exchange, they lack that information about the KYC. So they can't actually do that at the moment. One of the biggest pain points actually for financial markets as well, if you're a high frequency trader, you own a share. I own a share of a company. How do I know I really own that share? When I have a potential claim to it, I rely on this broker, let's say, that actually tell me I have this share, but you can sell it to 8 different people. There's 8 potential claims for one share. And blockchain solves a lot of those problems. Yeah. And actually the other big pain point as well is, they also have the idea of owning the share. Do I own the share? I own a piece of paper that's a claim to the share. Where cryptocurrencies allow you to have self-custody of that share. As a part associated in my key, and only I'm the one who can transfer that share. And that's really cool as a real use case. Financial systems the blockchains are basically reinventing the financial system from scratch.
Correct, but custody is something that if you ask anybody out of this room, like they don't feel comfortable to handle it, and probably that's a huge problem. Even for me, for example.
Yeah, so historically speaking, the key management problem, which is basically what it is, has been a big problem. So the zero-knowledge proofs, going back to store signature, was actually invented for you to log into a website, to remove username and passwords. But that was actually too hard because people couldn't do their keys. But now there's this financial incentive to actually keep your key secure. And for a lot of large institutions, they have the resources to do that. And even everyday people now can get like a little hardware wallet or a piece of paper. And if you've actually got like a lot of real-world assets there, you're going to do your best to keep that safe. Or you just revert to the banking system and use a custodian service like Coinbase. You can also do that. People do that. I do lose money for that. Yeah, the main point is that the financial system will now be auditable, transparent, and you don't have to trust a third party to use it. With this access is really exciting.
So Harry, as far as I know, you're a project at our university, right?
Yeah.
So how do you get the word out of what you're creating? It's actually really cool. I really like it. But how do you do that like in the real developers? Because universities, you know, like they experiment with stuff and you can find young developers, but production systems and real programs.
Yeah, I mean, it's a great question. For us, kind of fundamentally, when we started kind of working on research, and kind of from a research perspective, this issue of kind of scalability in blockchains is a really interesting question. And kind of fundamentally, you're starting with this incredibly inefficient system where it's a distributed system where the more nodes you add doesn't increase the capacity of the network in any way, which from a distributed systems perspective is atrocious. And so the kind of the question of like how can we improve on this is really interesting. And so kind of starting from that angle and starting with kind of the intellectual freedom that you get in a university to really kind of explore way out there solutions, I think kind of provided a really exciting opportunity to do a lot of thinking. And out of it, I think we came to a solution that we really love. And kind of along with that, the realization that this was something that needed both a lot of work to actually build and deploy, more than would ever be feasible for an academic project where you build a crappy beta with really bad source code and throw it online and then move on. And that having a fully formed version of this system could actually provide a lot of value and kind of improve the blockchain ecosystem, which is something I care about a lot. And kind of that inspired us to go in a direction that I think none of us had ever did kind of. I never had any interest in business whatsoever. Now I'm kind of one of the people running the company. And so I think kind of that drive to really push to the mainstream what I think is some pretty fundamentally important work is kind of why I'm here.
So Arjun, so you're like a implementation of Plasma, right? So do you think let me ask like in a different way because I know what to get. Do you think that Plasma really works? Okay, to follow up with the question is, even if it does, do you think that there is enough like awareness that it doesn't really throw people away? Because to me, like, I wouldn't use it as an engineer if I knew, as you said, like, if Ethereum wouldn't exist after 6 years, what about Plasma? Maybe 3 months.
Okay. Targeting the first question, answering the first question first. See, basically, the problem behind this perception of Plasma not working is because there is so many variants of Plasma that you hear from a lot of time, right? But if you kind of just hark back to it, the Plasma white paper just came in 2017 of August, right? If you think of something like state channels, for example, right? They've been in academic study like for say 50-20 years, right? And still they have not diverged or converged, sorry, right? Any new paradigm takes time to set in. So we started with like something with Plasma MVP. There's something called MoreVP that we implement. There's another variant called Plasma Cash, and there will be lots of variants. But the essential thing is the way in which the accept mechanisms are kind of built in. Those are Plasma Cash and Plasma MoreVP, and those are just the two flavors. Now, in terms of developers using Plasma to do it, right? Actually, Ethereum development, smart contract programming development, actually really took off, frankly, only in 2017, when there was a lot of hype, a lot of developers came into space, learned Solidity, got a bunch of good documentation, and now people are increasingly getting comfortable, but you can't say that, Solidity has taken the world by storm, right? You still have very few blockchain developers in the entire ecosystem. Now, so if you take that same metric and say, apply that to Plasma, I believe that with the right kind of tooling, I believe with the right kind of, I laid out a lot of points in my presentation earlier in terms of just minimizing the learning experience, right? There is going to be a ton of developer tooling that is going to come up. That happens with any technology. I very strongly believe that's why we based the company on Plasma. I think in the last 1 year we have done, I was chatting with Harry yesterday regarding the incredible progress that we've been doing in plasma engine channel L2 over the last 6 months, I would say, or 1 year. And it's been sensational, I would say. At least those who are very technically close to the subject, they know what kind of progress that we're doing. And I think it will become apparent to the general public as well. That's what I feel. And I forgot the second question. What was it?
So do you think that's an obstacle for people who want to develop like because they don't trust plasma, and just as plasma?
Okay, yeah. I think this question, someone asked this question to me in Berlin as well. From Lila, yeah. And so they're also doing plasma work, and he was very worried. And he talked to me like, people don't understand the difference between sidechain and plasma, for example, right? And there's such a big difference between these two implementations, and it is my sincere effort that we want to be more public. We want to make everyone more aware about the different security guarantees. In a conference like DevCon, for example, a lot of the attendees do understand these differences, but to the general world, it's right now very hard to just very simply explain what is the difference between a POA chain, a POS chain, a plasma chain. It's just I think it'll just take time, right? Right now, I can, see, there are so many white paper projects which say they can do 1 million TPS, right? That's not how it works, right? So,
and some of them won't change, and we've heard that.
Yeah. You can write a white paper on that. So I don't mean to discourage any project, and all I'm saying is this work on L2 takes effort, takes time, and any kind of developer awareness also takes time, tooling takes time. I believe with the right kind of tooling, right kind of education, right kind of documentation, developing on Plasma will be easier. We just released Plasma predicate support in September. I hope we improve predicate tooling support more and more. It will take time, but it will happen.
And to be clear, with Token, I've used your chain, and I gave you some feedback on that. It's really much different from any other thing that I've used, but to me it's something strange. It was just experimenting. So yeah.
I don't know if that meant as a compliment or not, but I think
it is a compliment. It is a compliment.
Thank you.
It's great. It's better than the worst.
Okay.
Yeah.
So
that's not question.
It's not it's just a numbers thing.
Yeah.
So I saw your presentation. You have 12,000 MAU or something.
Yeah.
So do they understand anything about the underlying technology, and do you think that the 12,000 has something to do with the fact that you're a blockchain company? Or
sorry, I'm not
the Celer X has 12,000 users, right?
Yeah. So I think I was trying to make it clear. When we do Celer X, we put it as a typical internet game app. That's it. We'll not even try to put the branding like a blockchain. I will put another way. / a blockchain label to the app. What's the difference it makes for user? I don't see it. Underneath, yes, the technology gives the user the kind of the non-custodial power. But as you mentioned earlier, do you trust yourself versus a bank? Do you trust yourself after 3 beers versus a bank? Yeah. And you remember where do you keep your recovery freeze? Right? And all these questions put the burden on the normal user. I think, I also come from a technical background. I definitely feel that Harry said earlier, we are so excited about the interest and the Patrick. That's my take.
I'm going to mostly agree, I think, with that take. I think you want to have a user experience that is like Web 2 to the degree that you're not waiting around for minutes on end for your transactions to confirm. You don't need to actively think too much about kind of the particulars of what happens in the background. But fundamentally, there needs to be something different, because otherwise, why not just build games and have a centralized server and distribute crypto? Why not be an exchange and essentially kind of fundamentally, you can't hide everything, because if you hide everything, then what's different than the existing world? There needs to be kind of some way that users can actually understand the kind of the security benefits they're getting, or else they will always prefer to just use existing centralized systems, which can provide a kind of significantly better user experience most of the time, or maybe equal. But at that point, what's the difference? I mean, there is a difference, but kind of you're not really showing it.
I have two answers to this. So the first one is that obviously I think there should be some, like the applications that make sense for cryptocurrencies is one, when the user requires self-custody, and two, when there's an application or an operator that you want to hold accountable and you don't trust. You know, if you have those two things in your app, hopefully you're going to go to the moon in the next few years. And that's really important. You know, applications on cryptocurrencies only make sense when you have those two pieces to the puzzle. So in that sense, you need to have some awareness if you're using a blockchain app to say, well, I do have self-custody. You know, I don't have to trust this operator anymore. Or I can say, oh, they've deviated. I can punish them because they're deviating and I can withdraw my money. The second one is, how do we improve the developer experience and whether they're using, you know, they're aware they're using blockchains. So the thing we're doing at Pisa at the moment is that we're going to abstract away the transaction stack from the developer. Ideally, we just provide a very simple API, and as a very simple API, you tell us the call data, you tell us what contract you care about, and we just send that off to you, or on your behalf. What's nice now is that, you know, the stop developer can pay some small subscription fee to us, and now all we do is take care of all the transactions for them. They don't have to care about rebumping fees, they don't have to care about, you know, chaining transactions, handling reorgs, hard forks. Transactions are just dealt with for them, and that's a big deal. So who here, for example, who's had a transaction linger for 6 hours? You know, you send a transaction, you have one. Anyone else? Lingering transaction, there you go, exactly, it's a pain in the ass. What is really nice is that a DApp developer can now outsource this to what I'm going to call a financially accountable third party, in the sense that if we don't do it for them, then they're entitled to a refund and we have to give it to them. They send evidence to the blockchain, we send the refund back, or we get slashed. And that's really cool. So that's exactly what we're doing at Pisa, trying to make it easier for DApp developers to actually build their dApps. Cool.
Yes?
Yeah, I mean, you guys, it feels like you're on my side, so I'm trying to make this exciting and tell you're all wrong, but I also agree that there has to, I'm going to say there has to be something that is different than Web 2.0, but it doesn't have to be harder. It has to be different. And what needs to happen is that in the actual traditional, in the world right now, the developers, the designers, the people that are really good at making user experiences aren't in this space yet. They will get here, and if you look at actually a lot of different big breakthroughs in technology, it takes time for those people to get into the space. And if you look at what brings them into the space, is development tools, is actually making it easy for them not to actually have to think so hard about getting their PhD in computer science to make sure that they can actually make things work. They want to actually just make things work for people, not for the computer. And that's why I believe that the pain point today is not necessarily trying to actually, for us to figure out what a good user experience is for an end user. Our job today is to actually make it so more people can get into the space, so that the people that have the strengths that need to figure these things out can come in and feel comfortable here. That is what we need to do.
I just want to add that besides we have to care about user experience, and I agree with Chris and Harry that we do not have to hide everything, and moreover, I guess we have educate people that that common users, they have to know about trustless system, about self-custody, and not to hide from them, but like open eyes for them. So there is a better world, and you can enjoy it.
Maybe what you could say is, I mean, if you're building a DApp such that you can actually hide the principal of self-custody, you know, to such a point where the user doesn't need to be aware that it exists, and this sort of like Harry's point, do you need a blockchain? You know, really any app on this should have self-custody.
Yeah, so I do have some answer to that. If you remember the map I showed earlier, the blockchain today already give you the power of, you could say a global level playing field, right? I always want to bring, one of our most active users are coming from Madagascar, and the reason he's playing so actively is because he can get direct access to DAI. That's equivalent to the US dollar. But that's the power of, you could argue the Ethereum with the ERC20 token ecosystem brings to the world, right? I think, again, I'm just, try to make it, we're not saying that, forget about blockchain completely, but from our point of view, it seems to be Ethereum and this, the ERC20 token ecosystem kind of already achieved the goal that as long as you have an internet, you have the access to a global financial market, right? And then the next task is how we can make it even more accessible. Like for users who do not want to write down all the 24 words for recovery phrase and save it in the nice line drawer, and put it somewhere and say, oh, we can still benefit from this ecosystem. I think that there's always kind of a wide spectrum of users, especially when you decide on your go-to-market strategy. Always the first thing you get reminded is make sure you understand which user segment you're going towards, right? There is always this kind of more sophisticated users with higher understanding about technology, and also you have the other almost extreme is your grandma. Our goal is more on that extreme. Say, grandma, download this app, you can use it. Yeah.
So I think we are 40 minutes, so it's getting late. So do you want to have some questions? Do you want to it's up to you. If you're hungry, there's pizza.
Yeah. Anybody want to ask questions?
What you got?
Great. So let's go to the day. Thanks.